When installing a subpanel for a kitchen rewire, several factors must be considered to ensure adequate capacity and prevent nuisance tripping. The existing main panel's limitations, particularly the neutral bar's wire size capacity, play a crucial role in determining the appropriate feeder size for the subpanel. Analyzing the load calculations for the new kitchen circuits is essential. A 15-amp circuit powers under cabinet xenon lights with a total of 80 watts. This load is relatively small and shouldn't significantly impact the overall demand. A 15-amp split-wired circuit serves the disposal and dishwasher. Given that these appliances are unlikely to operate simultaneously at full capacity, their combined load can be estimated conservatively. Two 20-amp circuits are dedicated to small appliances. Countertop appliances like coffee makers and toasters can draw significant current, especially when used concurrently. A 20-amp circuit powers the built-in microwave. Microwaves typically have a high power demand during operation. A 30-amp circuit supplies a dual fuel range. This appliance is the most significant load in the kitchen, as electric ranges can draw a substantial amount of current, particularly during oven operation. Estimating the total load without the range firstly involves calculating the load from the lighting circuit, which is 80 watts. To convert this to amps at 120 volts, divide the wattage by the voltage, which gives approximately 0.67 amps. Secondly, the dishwasher and disposal circuit must be considered. Assuming they don't operate simultaneously at full load, a conservative estimate would be around 10 amps. Thirdly, the two 20-amp small appliance circuits can potentially draw up to 40 amps combined. However, it's unlikely that all appliances on these circuits will operate at their maximum rating simultaneously. A demand factor can be applied here. Fourthly, the microwave draws a significant amount of current. A 20-amp circuit at 120 volts can handle a maximum of 2400 volt amps, which is approximately 20 amps. Summing these lows, 0.67 amps for lighting, 10 amps for the dishwasher and disposal, a reduced value of say 35 amps for the small appliance circuits after applying a demand factor, and 20 amps for the microwave yields a total of approximately 65.67 amps. However, these demand factors can be used according to the National Electrical Code, NEC. Without the range, the loads could approach 45 amps if all the lights are on, the small appliances are running on all the counter circuits, and the dishwasher or disposal are being used. This value is an estimate, and actual load may vary. With the range in operation, the load can easily exceed 50 amps. Electric ranges typically draw a significant amount of current, especially when the oven and burners are in use simultaneously. A 30-amp circuit might not be sufficient to handle the range's load along with the other kitchen appliances. Addressing the neutral bar limitation is essential. The existing main panel can only accommodate number 8 wire on the neutral bar. If planning to use a larger feeder size for the subpanel, this limitation must be addressed. Increasing the feeder size to number 6 wire can provide some additional capacity on the neutral, but it might not be a permanent solution. A number 6 copper conductor has an ampacity of 55 amps at 60 degrees Celsius, 65 amps at 75 degrees Celsius, and 75 amps at 90 degrees Celsius, according to NEC Table 310.15. B16. Selecting the appropriate temperature rating depends on the termination temperature ratings of the equipment. Replacing the main panel with one that can accept larger wire on the neutral bar is the most reliable solution. This will ensure sufficient capacity for the circuits and prevent overloading. The National Electrical Code, NEC, provides guidelines for calculating electrical loads and determining the appropriate feeder size for subpanels. Consulting the NEC and performing a load calculation is crucial to ensure compliance and safety. The NEC specifies demand factors that can be applied to certain loads, such as small appliance circuits, to account for the fact that not all appliances will operate at their maximum rating simultaneously. Proper grounding and bonding are essential for electrical safety. Ensure that the subpanel is properly grounded and bonded to the main panel and the grounding electrode system. Consider the voltage drop in the feeder conductors. Excessive voltage drop can cause appliances to operate inefficiently and can damage electrical equipment. Choose a feeder size that minimizes voltage drop to an acceptable level. Overcurrent protection is crucial to protect the feeder conductors in the subpanel from overloads and short circuits. Select a circuit breaker or fuses with an appropriate ampacity rating to provide adequate protection. A 50 amp breaker protecting the feeder to the subpanel might not be sufficient for the potential loads that might be encountered, especially with the range in operation. If the homeowners frequently cook or bake and use multiple countertop appliances, the load can easily exceed the capacity of the 50 amp breaker. It is preferable to provide an installation where the homeowners don't have to worry about overloading the system. This can be achieved by either increasing the feeder size or replacing the main panel. Replacing the main panel is the most reliable solution, as it eliminates the limitation of the neutral bar and provides ample capacity for future expansion. When selecting a new main panel, choose one with a higher ampacity rating and sufficient space for additional circuits. This will provide flexibility for future electrical needs. Consider the long-term electrical needs of the kitchen. If the homeowners plan to add more appliances or equipment in the future, it is advisable to install a subpanel with sufficient capacity to accommodate these future loads. Performing a thorough load calculation is essential to determine the appropriate feeder size and overcurrent protection for the subpanel. This calculation should take into account all of the connected loads, including lighting, appliances, and the range. Apply demand factors as permitted by the NEC to reduce the calculated load. The feeder conductors must be sized to carry the calculated load without exceeding their ampacity rating. The overcurrent protection device must be sized to protect the feeder conductors from overloads and short circuits. In summary, when rewiring a kitchen and installing a subpanel, consider firstly the limitations of the existing main panel, secondly the load calculations for the new circuits, thirdly the capacity of the neutral bar, fourthly the ampacity of the feeder conductors, fifthly the rating of the overcurrent protection device, sixthly the potential for future expansion, and seventhly the requirements of the National Electrical Code. By carefully considering these factors, a safe and reliable electrical installation can be ensured. If a larger wire cannot be accommodated, the main panel must be upgraded or replaced.